Hello serverless people, welcome to another video on AWS and serverless. In this video I want to cover the must-have alerts for a serverless application. A famous quote from Werner Vogel, I hope it's pronounced like this, the AWS CTO, is "Everything fails all the time." So you understand quickly that we need to be ready for this and design and monitor our application to be resilient. I got inspiration from a video published by AWS. I thought it would be useful to go deeper in details on how to increase observability of an application. Let's start from an example of a serverless application. As you can see here, is a sample application that processes events. There are different components, and of course, each of them can fail. So we have our client here calling an API through API Gateway. API Gateway has an integration with Lambda. Lambda pushes a message to SQS. Amazon SQS, the queue is consumed by a Lambda function. So the Lambda function has a trigger, which is the SQS queue, and is pushing the items into a DynamoDB table. All of this is monitored by CloudWatch, and also the Lambda consumer is going to push messages into an SNS topic. SNS stands for the Simple Notification Service of Amazon. I've made a video about the difference between SNS and SQS. I'm going to tag it here and also in the description. As I said at the beginning, we need to work on the observability of our application. The service that is going to help us is CloudWatch. AWS CloudWatch collects, access, and correlates data about AWS services. For this video, we'll focus on 5 main metrics: concurrency limit, errors, dead letter queue, delivery failures, and age of messages. Okay, let's start with the first one. Concurrency limit refers to the AWS Lambda service, but what is concurrency? So in AWS Lambda, the unit of scale is a concurrent execution. This refers to the number of executions of your function code that are happening at any given time. Each AWS account has 1000 concurrency limit per region. Okay, this is the default limit. So if you have a look on the graph here, the documentation, we're going to see the function concurrency that is going up and down depending on the load of your function. But when it hit the limit, we got a throttling, okay? When there is a throttling, the function is returning the 429 error code, HTTP code, which is like too many requests. And the goal here is to have a way to monitor those throttling events. So keep in mind that the 1000 concurrency limit is per region and not per function. So all functions for a single region counts for the total concurrency of 1000. What we can do is using the reserve concurrency option. So with reserve concurrency, we reserve the concurrency for specific function. As you can see here on the documentation, we are reserved like a number of concurrency function for the my function dev, same thing for my function prod, and then the other function, I'm going to have the difference between this reserved concurrency and the remaining one. So the reserved concurrency has the following effects. Other function can prevent your function from scaling. So basically what it means is that the other function, the ones with no the reserved concurrency, will not influence the concurrency of your function, which is basically what happens here in this graph. As you can see, the other function concurrency here in blue is not influencing the concurrency of the dev function or the prod function. And also the other thing is that your function is not gonna scale out of control, because when you put reserve concurrency, you also put like a roof. The reserve concurrency is basically the maximum number of execution that can happen for any given function. So if we put for my function dev, let's say 50 reserve concurrency, this function dev can only scale out to 50. When there is the 51 concurrent execution, we're going to have the throttling event. So this reserve concurrency feature is like a double feature, right? It put a roof on top of the maximum number of concurrency calls that your function can have, but also keep the concurrency reserved for your function only. Okay, let's go on the AWS console now. As you can see here is a very simple Lambda function. And if we go on the configuration, we see that we don't have any reserved concurrency at the moment. Now, what I'm going to do is, using like a load testing tool, I'm going to send 5,000 requests to this function with a 50 concurrency value. So basically, it's going to send 50 requests at a time up to 50,000. This function has a public URL using the new function URL feature. I also made a video about it. Feel free to watch it. It's in the description and also up here. So let's go on the EC2 instance now. Okay, I'm logged into the EC2 instance. Now I'm going to run the command of, as I said, 5,000 requests with 50 requests at a time. I type enter, and I will expect to have all 200 okay, so no throttling from the Lambda function, because we haven't set any reserved concurrency. And that's actually what happened. We got 5,200 okay responses. If we go on the metrics of our Lambda function, we should be able to see the same thing. So let's have a look. And as you can see, if we go on the invocation, we see here 5,000. Here is the duration. Here's like success rate 100%, and we have bunch of metrics here. So concurrent execution 68. That's good. No throttle, so 0. Now, what I want to do is to set reserved execution to 25, let's say, in order to trigger some throttle from the function. But before doing that, I want to set up an alarm. So if there are like some throttles from the function, I'm gonna receive an email, for example. We can do this in different ways. One way can be, let's count the throttles number. So if I have more than, let's say, 100 throttles per minute, I'm gonna send an alarm. Or we can even monitor the concurrent execution, right? So in this case, I want to monitor the concurrent executions. So since I want to set a reserved concurrent execution to 25, I want my function to be able to scale out up to 25. If I know that the concurrent execution is reaching this limit, the 25, I want to receive an alarm, because I want to be aware that we are very close to the limit. So let's do that. Let's go on the metrics dashboard. I click here. The concurrent executions metric is selected. If I go in here, I can create an alarm. So I'm going to create an alarm. Concurrent execution, my new function, URL function, statistic maximum. So no, I want to do average. Let's say average for, if the average for 1 minute is, let's say, greater or equal of 20, so it's like mostly 80% of the limit, I want to receive an alarm. So here I'm gonna select in alarm. I want to create a new topic, an SNS topic, and receive an email, for example. So here I'm gonna set my email and I'm gonna create the topic. Okay, I've created a topic. Now I'm gonna click next. Alarm name, I'm gonna say reserved limit. Reserved limit almost reached. Now click next. Preview, and actually we can review the conditions. So wherever concurrent execution is greater or equal than 20, great. So I'm going to create the alarm, and the alarm has been created. So the next step we have to do is, when you create an SNS topic and you set the email as a recipient, you need to confirm from your email that you want to receive emails from AWS. So I'm going to do that. Okay, as you can see, the subscription has been confirmed. Now I want to set the reserved concurrency and trigger the alarm. So I'm gonna go on the configuration, click edit here, reserve concurrency to 25, save, and now I'm gonna trigger the same requests, and I would expect to receive the alarm. So let me do it again. And I would expect the result to see some throttle. And yes, that's what happened. As I said, the throttle is like the 429 HTTP code, too many requests. And if you go on the metrics, we should be able to see the throttle count going up. Let's have a look. And yes, it works. So we see a spike here on the throttle. And the same thing, we see concurrent execution here of 32. And I just received the email of the alarm being triggered. I'm gonna show it to you now. As you can see, it's a simple email, say AWS notification, and it gives you all the details about the alarm that you have specified. So great, it worked. So for this point, your action point is create an alarm and keep monitoring the concurrent execution of the throttles number. Let's move to the second metrics now, the error. So the errors are basically the number of invocations that result in a function error. Function errors include exceptions like your code throws or exceptions that the Lambda runtime throws. So the runtime returns error for issues such as could be timeout or configuration errors. To calculate the error rate, you need to divide the value of errors by the value of invocation. Also, keep in mind that the timestamp of the error reflects the timestamp of when the function was invoked, not when the error occurred. So that's important to remember. And here, based on the SLA that you declare, let's say you declare 99% SLA, you can set the error alert to the 1%, right? So your action point for this metric will be to, again, go on the metrics menu, select the success rate here. You can also see the formula here, right? So it's 100 minus 100 per errors divided by the max of errors and invocation. So if we go in here again, we can create an alarm. And the idea is, as I said, based on your SLA, you can set the alarm threshold. So in this case is on the success rate, and we can set here, if success rate is lower, let's say that is lower than 99%, I want to receive an alert, right? I'm not going to create the alarm to show you on the previous step, but this is what you need to do. So the action point for this metric is to create the alarm for the success rate based on your SLA. Okay, now the third alert. The third alert that we need to monitor is the destination delivery failure. So Lambda function gets triggered by, can be triggered by async action, such could be an S3 event or a queue from the AWS service. When you invoke the function asynchronously, you don't want to wait for a response from the function code. You hand off the event to Lambda, and Lambda handles the rest. So to send records of asynchronous invocation to another service, you can add a destination to your function, basically. You can configure a separate destination for events that fail processing and events that are successfully processed. So basically, like you do the error handling settings, you can configure different destination of a function version of an alias. Okay? If we see this example from the documentation, we're going to see that when the function returns a success response or exit without throwing an error, Lambda sends a record of the invocation to an event bridge event bus here. When, on the other hand, the event fails, the Lambda sends the notification to an SQS queue. What this is going to tell us? This is basically telling us that setting an OnFailure destination is a very good idea. And how we can do that, I'm going to show you in a second. So we go on the console of your Lambda function. You go again on the configuration, and there should be a menu called destination. Here we go, it's here. And basically you can add your destination. So we said there could be two destinations, so the success or the failure. Here we're going to focus on the failure destination. You click on the add destination, asynchronous invocation, condition on failure. So when the Lambda fails, I want to send this event to, let's say, an SNS topic or an SQS queue. It depends on your use case. And here you select your destination. In this case, I don't have an SQS queue. So let's do an example with an SNS topic. And here you select your topic. You click save, and every time there is a failure, the Lambda function is going to send it to the SNS topic or to the destination you have selected. We can also monitor this metric from, again, the metrics of CloudWatch. And the specific metrics in this case is the async delivery failures, which is here. It's populated, but in our case, since we have just a very simple function, which is triggered by an HTTP endpoint, is nothing async. Next step you can do is to create an alarm on this metric, so the async delivery failure metric. So to summarize, the action point I will say is to create a destination on failure for your Lambda function if the Lambda function handles async events. A similar alert to the destinated failure, as it can actually be an alternative to the OnFailure destination, is the dead letter queue. So you can configure your function with a dead letter queue to save discarded events for further processing. So a dead letter queue acts very similar to the OnFailure destination, because every time there's like an event failure, the message is going to send to this dead letter queue. But what you can do with the dead letter queue, if you want to reprocess the events, you can set the dead letter queue as an event source for an additional Lambda function, like a Lambda function that handles these failure events. Or you can manually retrieve the events and see what went wrong. Maybe it's like a malformed event, and you can like analyze those events offline. You can choose both like SQS queue or an SNS topic as the dead letter queue destination. And again, for the dead letter queue, so if you want to add the dead letter queue to your function, you go on the configuration, you select the asynchronous invocation menu, you click here edit, and you select the dead letter queue. As I said, SQS or SNS. Here SNS, I select the topic and I click save. This way, for failures inside the Lambda function, I'm going to get the event into my dead letter queue. So your action point for this alert is to create a dead letter queue, and you can also monitor the metric called dead letters errors. So it's basically the number of dead letters queue that are triggered in a specific period of time. The last metric and alert that I want to analyze with you is the age of messages, right? So when you use Kinesis or Dynamo, you want to understand the age of messages to spot if there are like performance problems with your function. Let's see this example. Here we're using Amazon DynamoDB streams to trigger a Lambda function which send a message to an SNS topic every time there is a change on the status of an order, right? So what can happen is that if a message is too old, like the age of the message is too old, it means that the function is not keeping up with the amount of messages received from DynamoDB. The Iterator Age metric can help you with that. The problem you can experience with this is data loss, because the data in the streams are kept for only 24 hours. So if we go on the AWS console again, on our Lambda function, on the monitor, we will see the Iterator Age metrics. As you can see, it's here. The idea is you can create an alarm to monitor and spot if messages are too old. If they are too old, it means that your Lambda function is not keeping up with the amount of messages received. So the action point for this metric is to set up an alarm on the Iterator Age metric to monitor if the values are going too high. All right, and that's all for these must-have alerts for your serverless application video. I hope that it was useful. I hope I show you something that you didn't know about metrics, and also show you the power of CloudWatch and all the data collected by this service. Let me know if you have any questions. Please subscribe to the channel if you want to see more serverless content and help me a little bit with the content creation. Thanks again for watching, and see you on the next one. Cheers.